Hey, so we're trying something new. The kids told me that they wanted to see me on the lessons too. So there I am in the corner. This is what I look like after the kids go to bed. I'm ready to go to bed too. All right, but instead, I'm going to record 1.4 part 2. So 1.4 part 2 is a great lesson because it's kind of like solving an equation, except you don't actually have to solve it all the way. We're just going to be isolating for the variables that are indicated. So I suggest this is a great lesson for a highlighter. Speaking of which, I think I have an electronic one here. So I'm going to use my handy dandy yellow highlighter. It says solve for y. Go ahead and highlight the y. Pretend that's like glue that's going to lock it down. And the equation rules work the same as all equations. So if it's going to move across the equation line, you have to do the opposite. The only difference here is instead of just subtracting, adding, and multiplying, dividing numbers, we're going to be doing the same thing but with whole algebraic terms. So like for instance here, this is just a 7. We would just subtract 7, but instead we're going to subtract the whole term of 7x, which leaves us with y equals 8 minus 7x. Those are not like terms. So you have a choice. You can either write negative 7x plus 8 or 8 minus 7x. And our job was to isolate for y, and guess what? We did. So we're done. All right, letter B. Same thing. I'm going to highlight, or, in some cases you don't have a highlighter. You can just box in the t in this case. And I noticed that there's two things that are being multiplied to the term of just the t and r. So to undo multiplication, we're going to divide whatever we divide by on the right. We also have to divide by on the left. So over here they cancel and you get t equals, over here you have L over PR. And remember, your job is just to get the variable isolated, so when it's done, you're done. So frankly, I kind of like this manipulation of equations a little better than solving because you don't actually have to go through the effort of like grabbing the calculator and getting the answer. It's a neat little trick we're going to see later on when you have an equation that you want to evaluate it at various values. You can do it really quickly using technology if you have it isolated. And your science teachers love this. So here, we're going to isolate for the x. Look at my equation. I notice the term subtraction of 9y is kind of off to the side here. We can go ahead and add the 9y away from the x term, leaving me with 11x equals negative 4 plus 9y, not like terms. So you could write those in either order. I'm going to go with 9y minus 4. And then remember, your job is just to solve for x. So if you go ahead and divide by 11, they didn't say make it pretty, did they? So x equals 9y minus 4 over 11. Now, once in a while, you get something annoying like maybe an ACT or SAT question where they might write the answer as like 9 over 11y minus 4 over 11. So what they did in that case is they just went ahead and distributed the divide by 11 under both of the terms. Whoop-de-doo. All right, this next example is interesting because my first step on those three examples was to highlight whatever variable we're trying to target or isolate, and I can't really do that here because there's two y's in the problem and they're not like terms, so I can't combine them. So like, what are we gonna do? So what I'm going to show you is a trick called factoring out that common target value of y. So if I were to pull the y out in front of this expression, factoring out is kind of the opposite of distribution. Think about what would be left here if you divided each of these terms by a y. If I divided u by a y and u by a y, we'd be left with x minus, now y divided by y, yeah, they do cancel, but they don't just go away, right? There's still a 1. And then it equals 10 still. And remember, your job is to solve for y. Now that there's just one y in the problem, go ahead and box it in. And I know it's kind of ugly looking, but y is being multiplied by x minus 1. So to undo a multiplication of x minus 1, go ahead and divide by x minus 1. Fun! So remember, your job is just to isolate. They didn't say make it look a certain way. They literally just want you to get y by itself. Actually, the prettiest it can look. All right, so example E here is a fun one. I would normally say box in the A, but we have an issue. There's two A's in the problem. They're not even on the same side of the equation, so that's another problem. And we're going to find out in a second that just like on example D, they're not combinable in any way, so we're going to have to do that cute factoring out thing again. So first thing we have to do is collect all the A's to the same side. So I'm going to go ahead and subtract this 5A term over yonder. And it would be awesome if they were like terms. They are not. So we have AB minus 5A, and then still equals a 4 over here. So just like on the last example, I noticed that there is a common A in this expression on that side of the equation. So if we were to factor that A out, we would be left with, think about it, think of what's happening when you divide by A, B minus 5. So again, like distribution, except like the complete opposite. That's exactly what factoring is. We'll be all about factoring in a few weeks. All right, and then now I finally have one A left in the problem. Let's isolate him by dividing by his multiplier of B minus 5. All right, A equals, they didn't say make it pretty, 4 over B minus 5. I kind of like those problems. I don't know, a little weird. All right, and the letter F is a little better because they said isolate for B and there's only one B in the problem. It's kind of interesting because there's a lot of things happening. B's being added to 3A, he's being divided by 5. So you have to think about like mathematical, like solving algebraic equations and what you would do first to solve for it. So most of us would decide to get rid of this divide by 5 by multiplying by 5 on both sides of the equation. So gone. The sound effects totally help, right? Equals 20. And then remember, your job is to solve for this B. So I know it feels kind of weird because you feel like you're not doing anything. You are. You're doing something very important. You are isolating for the variable. So B equals 20 minus 3A, ugly, sorry, or negative 3A plus 20. Either answer would be fantastic. So this is fun because a lot of kids think that this skill kind of seems odd, and it does have a lot of uses as far as algebraic manipulation goes later on in algebra and subsequent classes after it. But when you take applied mathematics, which is fancy talk for science, and you want to use this math, you want to make sure it's usable. You don't want to have to do, 14 algebraic steps every single time that you have to like solve for something in a chemistry lab. So your chemistry and physics teachers are going to want you to have the skill down pat. This is not a chemistry example at all. This is a very boring example, but we like to give you boring examples in the notes so you can really see the math, right? So we have two types of tickets for this concert, adult and child, and write an equation. It's going to have a whole bunch of variables that represent the revenue from the concert. So let's start with like kind of a verbal model, because that way we know what our variables represent. So I know back in the day, your teacher used to have you like write an equation out and then like off to the side, write like R equals this and X equals this and Y equals this. Well, you don't have to do all that if you write a verbal model and then the equation underneath it. So your total revenue, which is money you take in, right, is going to be found by, let's see, what if we took the number of child tickets, writing. But remember, you got to multiply that by the cost of a child ticket. But then we got to do the same thing for the adult tickets, right? So a number of adult tickets. God, my handwriting gets like worse and worse as the hour goes on. Times the cost of a child ticket. Okay. Talk about some variables. So revenue, R, sounds good. And then number of children get, I don't know, X times cost of child ticket. I don't know. A, making stuff up. I don't know. Oh, A was kind of stupid though. Oh well. All right. Number of adult tickets. Y. Cost of child. Oh, geez, Pearson. Adult. Gosh. B, it's really late at night. I just want everyone to have sympathy for me. Okay, so now they're going to give me some actual information that I can go ahead and substitute, fancy word, into this equation. And then I'm going to solve this equation. Actually, I'm going to do that first for the variable that I want to figure out. So the whole question here is how much should I charge per child ticket? And they're going to give me various things that I'm going to plug in a second. So let's think about which one of these variables even represented how much I'm charging for a child. And that was right here. Remember the cost of a child ticket, which I so brilliantly decided to use an A to represent. So think about what we could do to isolate for this A. I think the first thing we would do is we would subtract this YB term over. Yuck. Again, does not have to be pretty, guys. I'm going to write down here. I'm running out of room. So I have R minus YB equals X times A. Who wouldn't choose A to represent number of child tickets? And then last step would be to divide by X. I know I have kind of like a hot mess going on in this equation right now, but this is the formula for like what I would program a machine to do. That way I wouldn't have to do a bunch of algebra problems over and over and over again. But watch how fast this is going to go. So they want the revenue, which we know is something. Oh, we know 25,000. So I need a little calculator help here, guys. 25,000 minus Y times B, which was the number of adult tickets times the price of an adult ticket, which is 2525 times 800. I don't know. Calculator help here. Ooh, 2,200. So don't judge me. I know I should be able to do this in my head. I'm not there right now, guys. Wait. All right. So it comes out to 4,800 up in the numerator. And what we're going to do is we're going to divide by how many children's tickets we expect to sell. And they're going to change it on us. That's why it was so neat for us to isolate for that particular setup, because look how fast this is going to go. Ready? If I plug in a 200 right here, 4,800 divided by 200 is 24. So apparently we should charge 24 bucks for all those kids. Seems like a bit of a ripoff. All right, so 300 children's tickets. If I plug a 300 in right here, that comes out to 16 bucks. Oh, it's getting cheaper. That makes sense. And then if I plug in a 400 right here, that would be 12. Right, so look how quick that was. So rather than doing all those algebraic steps 3 different times with kind of like large numbers in the equation, if you just isolate that equation once, and then it's all set up for you, and you can either program a machine, calculator, or computer, or I guess you could evaluate it yourself. It wouldn't be that hard in that particular example. But trust me when I tell you that your chemistry teachers, your physics teachers, all your applied science teachers are going to want you to really have that mathematical capability. So I'm thinking you might have done something like this back in Geo. This is the perimeter of a rectangle. It's 2 lengths plus 2 widths. And if I wanted to take this perimeter equation and isolate it for W, because maybe I was like trying to figure out what the width would be if I kept changing up the perimeter or changing up the length or whatever. I don't know. I don't teach geometry, so I don't know what you people do anymore. All right, so if I were to subtract 2 lengths from both sides here, ugh, am I not correct? This writing is like getting worse and worse. Because I'm tired. All right, divide by 2, divide by 2. And again, they didn't say like, oh, make sure it looks really, really pretty. No, they just said isolate W. So I, as an algebra teacher, I would totally accept P minus 2L over 2. Now, your geometry teacher might be a little pickier and decide that they want you to divide both of those terms by 2. So they might say like half the perimeter minus, and then 2L divided by 2 would just be length. Because, I don't know, maybe that'd be like easier math for like the silly sophomores to do. I don't know. Sorry, sophomores. All right. So, I don't know. You know. All right. So what follows up here is this is probably going to be your homework. Spoiler alert. But I want you to refer back to those notes examples. This is a skill that we're going to have to practice quite a bit because it feels a little unnatural and like incomplete at first. But once you get the hang of it, I think you're going to like it. So best of luck.